Greetings everyone. Today we're going to explore multiplying and dividing rational expressions. We do have a note sheet for this, but it's super easy to jot down in your notebook as well. First, let's take a moment to just review the basic rules of multiplying and dividing fractions. Remember that when you're multiplying fractions, you multiply straight across. And as always, if you can, reduce the fraction. When you're dividing fractions, we actually choose not to divide, and instead we multiply by the reciprocal. So let's go back to elementary school. We instead would multiply by 5 over 1, multiply straight across, and reduce if necessary. We're going to incorporate our previous lesson of simplifying rationals, meaning you can cancel factors but not terms. Let's start off a little more basic. In this first one, we're going to approach this multiplying straight across. When you multiply like bases, you add their exponents. We'll multiply straight across in the denominator. When you multiply like bases, you add the exponents. And then we're going to simplify. Oops, excuse me, trying to erase that. Then we're going to simplify each piece. So I look at it as 4 over 28, right? That reduces down to 1/7. Then we look at the x's. If I have 2 on top and 4 on bottom, I have 2 remaining on bottom. That's going back to our basic rules of dividing like bases. If I have 2 y's on top and 2 y's on bottom, that simplifies to 1. And if I have 2 z's on top and 1 on bottom, that leaves me with 1 on top. This would be the quickest approach, but you could also simplify each fraction in itself and then multiply straight across. So if you find another way, if your work doesn't look the same, that doesn't mean you're wrong, especially when you have all of these individual terms. Now let's increase the complexity. Now we're dealing with a situation where we have polynomials. Just like simplifying rational expressions, which we already did, you want to factor first. Now my goal is I want to factor each piece, each numerator, each denominator. So I see I can factor out a 4x. I see that I have a level of try-factoring here. A 3 and a 2 can get me to a positive 1. Try-factoring in the bottom left. A 3 and a 1 would have to be positive, negative, and that 4x falls down. Now the nice thing about multiplying straight across, and this is sort of a cheat or a shortcut, is I'm just going to extend that line across, right? For multiplying straight across, it's like I have one big fraction. Now I can see what factors cancel. Be very careful. You can only cancel factors and not terms. So guess what? All of this simplifies down to x minus 2. Let's try another one. Now the style of this one, you'll notice I'm multiplying it by a polynomial, and I'm going to put that polynomial over 1. It's easier to think of each piece as its own fraction. So I've got an x plus 2. I'm going to take care of this denominator right away, which is x plus 2x minus 2. Denominator of 1. I have some try-factoring here. You want to make sure those skills are strong and good to go. Makes it a lot faster. Now the sort of shortcut would be to multiply straight across or make it one big fraction. And let's cancel like factors. And in this case, that's the only thing that cancels. So I'm left with x plus 3, x minus 3, and x minus 2. Now if you want to re-multiply that numerator, you can, but it's not necessary. Alrighty, let's take a look at this example. And the first thing you'll notice is we've now changed to a dividing problem. So when I start my factoring, I actually take care of the flip right away. So this denominator is try-factoring, but it's going to become my numerator. Now keep in mind you always flip the second fraction. You multiply by the reciprocal of the second one. That does make a difference, so be careful. Then my numerator becomes my denominator, and I just have a GCF on that one. The first one I'm going to leave as is, and let's see, I can take out a GCF here as well. Now I follow the same rules, multiply straight across, and I can cancel like factors only. Let's see, so those cancel. I have an X and an X. So I am actually left with the fraction of 2/3. Now let's make things a little more complicated. As with any algebraic expression, we want to follow the general PEMDAS rules. So I want to take care of the parentheses first. So I'm only going to deal with that. So I'm going to factor this first numerator, bring down the denominator. This numerator stays the same, and I've got some try-factoring here. Let's see, 6 and 2, nope, 4 and 3 is what I need, whoops. 4 and 3 plus. I'm multiplying straight across, so I'm just going to extend that line. Plus 3 cancels, and that's really all that cancels, right? Okay, so what that means is what I have left in parentheses, be very careful here, is the entire fraction x minus 3, x plus 10, x plus 3, x plus 10, excuse me, plus 4. Now if I bring down this first one and the rest of my work here, I have an x cubed plus 10x squared over 1. And I'm dividing it by what I just found. So I need to flip that entire piece that I just found. Okay, so first of all, I'm going to divide out an x squared here. It's still all over 1. I'm changing this to multiplication, and I'm flipping my entire fraction, my entire rational expression. Do you see what I did there? Now I can treat this as multiplication straight across. Now I can see that x plus 10, those factors cancel. And to be honest, those are the only factors that cancel. So I am left with an x squared, x plus 3, x plus 4, all over x minus 3. So you'll notice in some examples almost everything canceled. And in some examples like this one, very little cancels. So you can't have expectations going in, you just want to make sure to follow the rules carefully. Alrighty, so quick review. Don't forget all your rules about simplifying rationals. That involves a lot of factoring, so make sure that you're good to go there. Make sure you remember the rules about multiplying and dividing fractions. And if you need to go down to the basics, don't forget your basic PEMDAS rules, right? So if you need to take care of some parentheses first, make sure to do that. As always, make sure you check out Google Classroom to see what the task is to go with this lesson. Let me know if you have any questions, and until next time, have a good one.